This is honors pre-calculus and pre-calculus, Unit 7 and Lesson 6, equations of a geometric sequence. Let me do just a little bit of review about an arithmetic sequence, and then we'll compare the two. In an arithmetic sequence, we have a starting value, and then we have a common difference. So 5 plus 3 is 8, plus 3 is 11, plus 3 is 14, plus 3 is 17, plus 3 is 20. So this is an arithmetic sequence in which the common difference, d, is 3. Okay, and the start value, a1, is 5, right? And so we can define it a number of ways. We can define it recursively. As a1 equals 5, and a sub n equals a sub n minus 1 plus d, or plus 3 in this case. Okay, we can define it explicitly. A sub n equals a sub 1 plus n minus 1 times d. Okay. And it's linear in nature, so when we graph it, it forms a straight line. The points form a straight line. And if we graph the x-axis as the n-axis, okay, that's an arithmetic sequence. Okay, now we're going to look at another sequence. I'm going to start with 5 again. But we're going to do this. I'm going to do 5, 15, 45, 135, and so on. Okay? And take a moment to see if you can figure out what I'm doing and what rule I'm using. Okay? Now, hopefully you figured that out, and you've noticed that I am multiplying by 3. So we have, again, a first term, a sub 1. We don't have a common difference, we have a common ratio. The ratio of each term to its previous term is 3. That is, if I divide 15 by 5, I get 3. If I divide 45 by 15, I get 3. 135 divided by 45 is 3. Okay? So we can define this recursively this way. A sub 1 is 5. A sub n is a sub 1 times the common ratio. Hold on. Yeah, a sub 1 times the common ratio. There we go. Or a sub n minus 1. I'm mixing up explicit and recursive. A sub n minus 1 times r. Okay, so we take the previous term, we multiply by the common ratio. The explicit formula is a little less intuitive, but let me go ahead and make a table and see if we can figure this out. If we graph or plot n, right, let n equal 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay, and we get each term a sub n. We're going to start with 5, 15, 45, 135, okay, and so on. Okay, you'll notice you get each one by multiplying by 5. So this one is just 5. This one is 5 times 5, or 5 times 3. This one is 5 times 3 times 3, because each one is the previous one times 3. This one is 5 times 3 times 3 times 3. Whatever number this is going to be 5 times 3 times 3 times 3 times 3. Now let's rewrite this with exponents. This is 5 times 3 to the 4th. This is 5 times 3 to the 3rd. This is 5 times 3 to the 2nd. This is 5 times 3 to the 1. And this is 5 times 3 to the 0. Okay. So in general, look at the relationship. N is 5, the exponent is 4. N is 4, the exponent is 3. N is 3, the exponent is 2. The exponent is always 1 less. So here we go with an explicit formula. The explicit formula is, drum roll please, a sub n equals a sub n minus 1 times r to the n minus 1. So, not a sub n minus 1, a sub 1 times r to the n minus 1. There we go. All right. And so we can use this to answer all kinds of questions about geometric series. So, for example, I could find the, say, the 15th term. What is a sub 15? Okay, and here I go. General. I needed to generalize or make this more specific. Okay, r is 3. R is 3. So 3 times a sub n minus 1, and a sub 1 is 5, and r is 3. Be consistent. All right, 5 times 3 to the n minus 1. Okay, so a sub 15. So that's going to be 5 times 3 to the 15 minus 1. Or 5 times 3 to the 14th. And I'll let you do the arithmetic on that with your calculator. Okay. Now we get to some of the same types of questions we had before with the arithmetic series. Could you, if you were given a term of a sequence, tell me the original, right? So let's say we've got this. We've got a sub 8 is 1024. Okay, and we're given the ratio is 2. Okay, so the question then might be, what is a sub 1 or a sub any other thing? Okay, so a sub 1, what would a sub 1 be? There's two approaches to this. You can do this. A sub 8 equals a sub 1 times the common ratio 2 to the power of n minus 1. And then we can fill in what we know. We know the common ratio is 2. We know the 8th term is 1024. Okay, n is 8. N is 8. Okay, and we have 1024 equals a sub 1 times 2 to the 7th, which I believe is 128. Okay, and we can divide. So a sub 1 is 1024 divided by 128, which is 8, right? Okay, so that's one way. Another way is simply this. To get from 8 to 1, I go through 7 iterations. 8 minus 1 is 7. So I'm going to go backwards through the series. I'm going to divide by 2 7 times. So 1024 divided by 2 to the 7th power gives me the same answer, and it's the same arithmetic. Okay? And what if I wanted to find the 5th term? Okay, in that case, I would do 8 minus 5 is 3, so I'd do 1024 divided by 2 to the 3rd power. Okay, so we can use that. Then there's something called the geometric mean. Let me do that here. Okay, let's say I've got some number, 6, comma, blank, 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 and 100. And I'm looking for the geometric, we're told this is a geometric series and I need to fill in the blanks. Okay, well, think of it this way. You multiply 6 times the ratio to get the next term. You multiply that by the same ratio, so 6 times the ratio squared, 6 times the ratio cubed, and this one should be 6 times the ratio to the 4th. So those should be equal. So 6 times the common ratio to the 4th is 100. Ratio to the 4th is 100 divided by 6, which is 50 divided by 3. And the ratio, the common ratio, is the 4th root of 50/3. Okay. All right, so that's how to fill in the missing steps of the geometric series. And hopefully that helps.